All right, so on the next page, what we want to do, right, we want to actually uh, plot the data. All right, so to plot the data, we come back here, and we can hit the Stat button and hit Enter. And we want to input our data. So you go back and look at your table, and you put it in. So you have 0, 10, 20, 30, and 40. And then put in your outputs over here on the right. So 5.921, 11.185, 12.247, 14.261, and then 17.488. All right, so here's my data. Right here. And now what I want to do is I want to plot it. So I go to y equals. Make sure my plot's on. So I hit up, enter. My plot is now on. So I hit down and you can see it's highlighted. And then I got to zoom into the stat stuff. I tell my calculator where to look. So I scroll around. I find zoom stat. And I hit enter. And I get a nice looking plot. And so over here I can copy that down. So that's what I'll do. And I have a bunch of little boxes, so just draw them, make them approximate. Goes up a little more, up a little higher, still a little bit higher here. I'll label my inputs. So my inputs, I start at 0, then I have 10, then I have 20, then I have 30, and finally I have 40. All right. And then for down here, I'll label my times. This is time, T, and years since 1965. All right. And my output, okay, this is enrollment. All right, so I'll label this as in enrollment E in millions of students. And I should probably put some numbers on my vertical axis. So to do that, I'll go back to my calculator. And if you just hit the window button, it'll tell you where you kind of start. So Ymin is 3.95. So I'll start down here, maybe put 3.95. And the maximum value up here looks to be about 19.45. So I'll put 19.45. And I should probably title this. So this is enrollment in colleges. So I'll title it enrollment in colleges. Okay, and so now on the next step, it tells me that it says use linear regression to find a linear function that will model E as a function of T and graph this function on your plot above. All right, so to do this, I simply go back to my calculator. I want to use linear regression, so I hit stat, go over to calculate, go down to linreg, and hit enter again, and out pops my answer. So E of T is equal to, and so this is then 0.2621, right, times x, but my input is the letter T, so times T, and then plus 6.9784. All right, now I want to plot this on my plot. I graph it on my plot, so I pull up my calculator again, and I can see it on here. I can put in 0.2621 x plus a 6.9784. Hit the graph button. You see you get a nice looking line. It kind of travels through some of these points. Right, so I get a line that looks kind of like that. It's just approximate. And then I want to answer these following questions. All right, so use the linear model to estimate the enrollment in 1965. Is it close to the actual enrollment? Okay, so the enrollment in 1965, let's t equals 0, or you could just look and say it's this number right here. So the initial enrollment from my linear model is 6.9784 million students. If you look at the enrollment in the table, it's 5.921, and so you can conclude, is it close to the actual enrollment? Well, it's about 1 million off, right? So it is about 1 million off from the actual. Value. Is it close? Well, it depends on what you're considering, I guess. Is 1 million close to 6.9784 million? Maybe you think it is, maybe you think it's not, right? It's really up to the person that's working the problem. All right, so now we want to use the linear model to predict how the student enrollment is changing each year. All right, so you can use a little bit of logic on this one. This was the initial, and we put it there, so this number must be how it's changing, and it is. Remember, this number is like the slope, like the rate of change, and so this is 0.2621, and the most important part is the units. All right, so this is output over input. Right, that's how you find the slope, this rate of change, like the rise and the run. So the output is the millions of students. And then it's divided by the input, which is years. Right, so this is how it tells you how everything's changing. 0.2621 million students per year. I guess we don't need years, just per year. Okay, in part H, it says that we want to use exponential regression to find and that should say exponential function. That will model P, that should say E, right, as a function of T, and graph this function on your plot above. Round regression parameters to 3 decimal places. All right. So now, again, we'll pull up our calculator. So pull up your calculator. And to do this one, we're going to hit Stat, go to Calculate, but instead of linreg, we'll go down, scroll around, and we'll find exponential reg, and hit Enter again, and out pops my answer here. So on this one, my E of t is equal to 7.111, it says around to 3 decimal places, times 1.024. And it says to the x, but we'll write to the t. Okay. The next part is we want to plot this on our plot above, and so we can come back up here, and to plot it, it's real simple, right? Hit y equals, and we can just hit Enter, and we'll plot it on here along with the line, so we can hit 7.111 times 1.024 raised to the x, and then hit Graph, and we should see the graph of this over here, and then we can draw it on top of our graph right up here. And so it starts here and it kind of goes this and then kind of comes up like that. And so that's a good little picture there.